We are doing a dosing problem. When we look at the order, it is for 750 milligrams orally 4 times a day. We're asked to use a label, and we're asked how many tablets we will administer per dose. Dosing problems can be done using one of 3 methods. No matter which method we use, we need to identify what is ordered and what is available. Based on the problem, the order is for 750 milligrams. The available med is gotten off the label. On the label, we have the strength of the med as 0.5 grams, and we need to have that as a fraction, so we'll pair that per tablet. When we're working with tablets, it is always assumed that the strength is per 1 tablet, not for the full bottle. The first approach that we'll use is the dimensional analysis approach. We'll start with the order of 750 milligrams and place it over 1. Next, we'll use the strength of the medication. In this medication, we have 0.5 grams. Normally, I'd put that on the bottom, but I see that that will not cancel with the milligrams. So I'm going to need to convert the milligrams into grams in order to use the strength of the med. From my memorized conversions, I know that there are 1,000 milligrams to 1 gram. This allows me to cancel the label of milligrams. Now I can use the strength of the med. There are 0.5 grams per 1 tablet. This allows me to cancel the label of grams. I have my answer in tablets, which is what I want, so I'm ready to do the math. When I do the math, I find that the answer is 1.5 tablets, or 1 1/2 tablets. Let's look at the nursing formula approach. Our desired amount is the 750 milligrams. We have 0.5 grams in 1 tablet, so the 1 tablet is the quantity. I have a problem because the labels from desired and have do not cancel. In order to cancel the labels, I'm going to need to move my decimal. Typically, the decimal is moved in the order. So the desired amount will move from 750 milligrams into grams. I remember my metric line, so I'm picturing in my head King Henry died by drinking chocolate milk full of microorganisms. And I use that to move my decimal 3 places from milli to the base. So my new amount for the desired is 0.75 grams. Now the labels from desired and have cancel, and so I'm ready to do the math. On my calculator, 0.75 divided by 5 times 1 gives me an answer of 1 1/2 tablets. My final method is the proportion approach. In the proportion approach, I start with what I want to give my patient, so 750 milligrams. I put this over X tablets because I want to give the amount of med in tablets. I put an equal sign, and I try to use the strength of the med, which is 0.5 grams per 1 tablet. I don't have a true proportion because the labels don't match. Milligrams on the top of the left-hand side, grams on the top of the right-hand side. So what I need to use is my King Henry to move the decimal. So King Henry died by drinking chocolate milk full of microorganisms. To move from milli up to the base unit, I need to move my decimal 3 places. So this allows me to change the order to 0.75 grams. Now I have a true proportion because I have the same labels on the top and bottom of both fractions. I use the cross product on my first diagonal. I get 0.75, and that equals 0.5x. Divide both sides by 0.5 to isolate the variable. The 0.5's cancel, and I have x equals 1.5. And when I look back at my original proportion, the x had a label of tablets, so this is 1.5 tablets.